years, Earth's inner core has been rotating eastward, in the same direction as the planet. But recently, this rotation has stopped and even reversed. According to a new study published in the journal Nature Geoscience. This is part of scientists' efforts to elucidate deep geological processes inside Earth. Changes in the inner core's rotational motion may occur in multi-decadal cycles. This discovery is significant for our understanding of how the core influences Earth's other layers. So what is happening inside Earth? Our planet is composed of several distinct layers. The outermost thin layer, called the crust, is primarily solid rock and typically about 32 to 48 kilometers thick on continents. Meanwhile, in the oceans, the average thickness is only about 6.4 kilometers. Beneath the crust is the mantle, about 2,900 kilometers thick, accounting for 84% of Earth's total. This layer consists of denser rock material than the crust and is mostly solid, although some localized areas may be molten due to high pressure. Below the mantle is Earth's core, consisting of an outer and an inner part. The outer core is about 2,253 kilometers thick, primarily composed of liquid. At the planet's center is the extremely dense inner core, about 1,207 kilometers thick and believed to be solid. It is mainly composed of iron along with small amounts of nickel and other elements. In the mid-1990s, one of the authors of the newly published study, Xiao Zhongsheng from the Sinopot Laboratory, School of Earth and Space Sciences, Peking University, China, collaborating with Paul Richer at Columbia University, published the first evidence of the inner core's independent rotational motion. They found that the inner core rotates eastward in the same direction as Earth, but slightly faster than the mantle and surface. This rotation is influenced by magnetic and electrical effects in the surrounding liquid outer core, as well as gravitational interactions with the mantle. However, since that discovery, some unresolved issues remain regarding our understanding of the inner core's rotational motion, such as the rotation speed and whether the direction of rotation changes. These issues have driven researchers to collect more data over longer periods to test various models. Specifically, they analyzed seismic waves generated by repeated earthquakes passing through Earth's core since the 1960s. Earth's core may be starting to rotate in the opposite direction. The research team stated that seismic waves from repeating earthquakes typically have identical waveforms, originating from the same source. However, when waves from repeating earthquakes interact with Earth's inner core, they may display different waveforms and arrival times due to reflecting different structures within the core. Using these seismic waves, researchers can infer the inner core's rotation pattern over the past decades, revealing new details about this process and its connection to Earth's other layers. Their findings indicate that the inner core rotated faster than the mantle and Earth's surface eastward from the early 1970s until around 2009. After that, the rotation appeared to pause from 2009 to 2011 or longer. Since that period, the rotation seems to be gradually reversing. The authors state that evidence for the rotation reversal since 2009 is statistically very clear with over 95% confidence. They also suggest these changes may be part of an oscillation occurring over about 7 decades, with a similar shift having occurred in the early 1970s. These results help us better understand how Earth's inner core operates and how the different layers interact with each other as a whole. Such multi-decadal oscillations also exist in Earth's other layers, such as the outer core, mantle, and surface, indicating resonance within the same planet is entirely possible. Accordingly, there are two main forces acting on the inner core. The first is the electromagnetic force. Earth's magnetic field is generated by the motion of molten metal in the outer core. This magnetic field acts on the inner core, believed to cause it to rotate. The other force acting on the inner core is gravitational force. The mantle and inner core have significant differences in physical properties. Therefore, the gravitational force between them tends to pull the inner core toward a gravitational equilibrium position. Researchers conclude that if the two forces are unbalanced, the inner core will accelerate or decelerate. The 70-year oscillation cycle of the inner core is likely driven by electromagnetic and gravitation. This oscillation correlates with similar periodic changes in other geophysical observations, such as variations in the magnetic field or day length. The rotation direction of the inner core relates to the magnetic field, due to the electromagnetic force between the inner core and the magnetic field. The rotation direction also relates to day length, due to the effect of gravitational force between the inner core and the mantle. The gravitational interaction between these two regions may also affect the deformation of the mantle and Earth's surface. Understanding how our planet operates allows for explaining certain natural phenomena like earthquakes, volcanic eruptions, and especially the origin of the gravitational field. From accumulated knowledge, we can better understand other planets in the universe, places that could potentially become humanity's next home. Subscribe to the Hidden_Realms channel to watch the latest videos.